Hello. So let's talk about exponents and bases, okay? So what's the number a to a power 3? That's just a product of the number a by itself and itself. 3 times. I put the number a here 3 times, okay? The number a to the power 2, also known as a squared, it's just a product of a with itself. So I have a cubed, or a to the power 3, 3 repetitions of a squared, 2 repetitions of a. What is changing here on the left? So the base is the same, a, the exponent goes down from 3 to 2. So the exponent goes down by 1. And here I'm multiplying by a one last time. Here I have 3 a's, now I have 2. So in terms of algebra, what's happening here is this number here is the top number divided by a. So I'm dividing by a, this number to get to this number. Okay? Here when I move from a squared to a to the power 1, which is just a, I'm doing the same thing. A squared, I have a times a to the power 1, I have just one copy of a. So what's the relation between this number and this number? Well, to move down, I'm dividing by a. Okay, I'm dividing by a, and the 2 copies become just one copy of a. And here's the same thing. From a to the power 1 to a to the power 0, I'm dividing by a. So I continue this process of dividing by a. I have a to the power 0, I decrease my exponent by 1, I have a to the power 1. And what do I have to do here to get to the next? I have to divide by a again. And from a to the power minus 1 to get to a to the power minus 2, I have to divide by a. So every time I go from one line to the next, the exponent goes down by 1. And the number itself is divided by a. And to move up, what do I have to do? I have to multiply by a. I have to always multiply by a to get one more copy of a. Right? So here, if I multiply this number by a on top, becomes just, I cancel a, and I end up with this. If I have this number and I multiply by a, I cancel the denominator and I have 1. If I have this number and I multiply by a, I get this number. If I have a and multiply by a, I find this number. Okay, so going up means multiply by a, each line once, and going down means divide by a. Okay, and off you go. Moreover, we have this property as well. So if I have 2 copies of a and I multiply by a cubed, a squared times a cubed, I have a squared is a times a times a cubed, a times a times a. How many copies? I'm multiplying a times a times a times a times a. 5 a's, right? I had 2 times in blue here, 3 in red. Overall, I have 5 a's. 1, 2, 3, 4, 5. So I have a to the power 5. If I have a to the power 2 times a to the power 3, I end up with a to the power 5. In general, if these are the exponents, a to the power k times a to the power n equals a to the power k plus n. That formula holds in general. Okay? Now here I have a square cubed. Everything, first I calculate a square, and whatever I find, I raise to the power 3. So that means a squared times a squared times a squared. 3 copies of what's inside here, a squared. But a squared is a times a, so inside each parenthesis, I just write a times a, which is what a squared is. Then, when I have this parenthesis, these are kind of unnecessary. I'm multiplying. Multiplication is associative and commutative, so it doesn't matter. I just eliminate the parentheses and write the same thing. which means I have 6 copies of a. So it's a to the power 6. Okay? Here I'm writing 6 copies of a and putting parentheses in some other way. And this I have 3 copies, and here I have another 3 copies. Okay? So this is a cubed times a cubed, or a cubed square. So in general, if I have a to the power 2 to the power 3 or a to the power 3 to the power 2, it doesn't matter. Both are equal to a to the power 6. So I'm multiplying the 2 times 3 to get the actual power here that I have. Okay? And in general, if I have a to the power k to the power everything to the power n, is just a to the power the product of k and n. And if I flip the order here of k and n, that's okay, that's not a problem. That's what I did here. I flipped the order of 3 and 2, and 2 and 3 here. It's the product anyway, and the product is commutative. 2 times 3 equals 3 times 2. So it doesn't matter, okay? Very nice properties of exponents, very important properties of exponents. In particular, I like this one here. If you raise to the power minus 1, you are inverting the number. To do that, of course, the base a has to be different from 0, because we cannot divide by 0, but other than that, that's a very nice way of writing something. Okay? See you next time. Bye-bye.